All right, so we're going to compare inequalities. We have the or and inequalities, and do a quick comparison with bubble maps with or inequalities. And I'm going to take some simple examples here. We're going to have something like x is less than 3 or x is greater than 6. And let's look at what that looks like on a number line. We notice that this is going to be, if this is 0, that's 3, and that's 6. This is open circle left, and this is open circle right. Handlebars. So we write in handlebars. So this is remembering that there's a specific type of look to it. And we can have a number of solutions from both of these sides, and that means there's a lot of different solutions. And we can have anything from examples -3, for instance, or 0, or 2. Those, or we can have solutions from the right-hand side, so we can have 7, 9, 10. All of these solutions are part of a solution set that would be considered numbers that are true, numbers that make this true. We can get numbers over here, we can get numbers over here that will make this true, because it doesn't have to be true for both, it just has to be true for one or the other. So I'm going to write that in there. Solutions. What is the nature of the solutions? The solutions are numbers that need to be true to make the inequality true for one or other side. So in other words, it does not have to make the inequality, it does not have to make both inequalities. To make one, I would say one of the inequalities true. So it doesn't have to be both. And we'll see what that looks like when we do and. Over here in and, let's take an example of what an and situation would be. Let's do x is less than 6 and we'll make it less than or equal to 6. And x is greater than 3. So let's have a look at what that ends up being. We're going to, if you've done your work and you remember what we talked about, again, we have the same numbers. We have 3 and 6. We have a very different solution set. Less than or equal to 6 is going to go left, and greater than 3 is going to go right. And our solutions are all going to be in here, even though we have solutions that are greater than 3, things like 5, 10, 20, but they're not going to work for both of these. So we're only going to get a limited number of numbers that are going to work for both. What does it look like? Well, we've talked about it. We've been doing some fun mustache sketching like our furry friends in Class Dojo. So here's a chance to do a little bit of our own. So we've got the mustache answer, I guess you could say, or description. That's just for fun. I don't think you'll find that in a textbook, but hey, it works for us. I hope it works for you. It seems to be working for most people. So anyway, the numbers here, what are we, let's put examples of numbers that work for both of these inequalities. It would be like things like 4 and 5 and 5.5, but it would not be 6.5 because it wouldn't work for both. So examples, and then what is the nature of the solutions? What can we say about the solutions? The solutions need to make both of the inequalities true. They need to make both of the inequalities true. And there you go. And that's it. That's it. That's the comparison of these two types of inequalities, or and. All right.